Hello everyone, welcome to our Engineering Exercise Resolution channel. Today we will continue solving support reaction exercise, an extremely important topic for static mechanics engineering. If you want to master this essential subject, you are in the right place. Let's get to the exercise statement. Determine the horizontal and vertical components of the reaction at pin A and the reaction of the roller support B on the pin. To start, let's go to the first step, which is the free body diagram. At point A, we have the x component, which is RAX, and the y component, IAY. We also have the force of 4 kilonewtons acting downward. At point B, we have the components Rbx and Rby. Now, let's insert the measurement relative to the points, as they will be used in the moment calculation, and also the first Rb, which generates the components with the 30 angle. Any questions about this step, please add them in the comments for better explanation. Now, let's apply the moment equation using point B as a reference. The sum of moments relative to point B is equal to 0. Therefore, we have minus RAY, which creates a clockwise moment, times the distance to point B, 8 meters, which are 6 plus 2 meters, plus the force of 4 kilonewtons, which creates a counterclockwise moment, times the distance of 2 meters in relation to point B, equal to 0. The reactance components at B are not included in this calculation, as the distance to point B of these components is 0. Let's solve our equation to find the value of RAY. We have that RAY is equal to 1 kilonewtons. If you have any questions, write them in the comments. This helps us a lot to improve our content and convey the information more clearly. And let us know what you think about our content so far. This strengthens us, help us improve our content. If you are enjoying our content and want to support the channel, consider becoming a member. As a member, you will get exclusive benefits like asking for a specific exercise solution and much more. Click the join button below to learn more. Continuing with our resolution, let's move on the equilibrium equations, starting with the sum of forces in y. We have that RAY, which is 1 kilonewton in the positive direction, minus the force of 4 kilonewtons plus RBY is equal to 0. Thus, we have that RBY is equal to 3 kilonewtons. Now let's calculate Rbx and Rb using the decomposition method. We have that Rby is equal to Rb times the cosine of 30 degrees, and that Rbx is equal to Rb times the sine of 30 degrees. An important tip: whenever we want the vector adjacent to the angle or the vector forming our angle, we use cosine. When we want the vector opposite that the angle, we use sine. We can now solve the equations. Rb is equal to 3 divided by the cosine of 30 degrees. So we have Rb is equal to 0.464 kilonewtons. For Rbx, since we already know the value of Rb, we substitute it into the equation to find Rbx is equal to 1.732 kilonewtons. To finish, let's apply the sum of forces in x. Going back to our third step to find Rax. The sum of forces in x is equal to 0. So we have that Rax minus Rbx equal to 0. This means that RAX is equal to RBX, giving us RAX equal to 1.732 kilonewtons. And that is it, folks. We have solved another static mechanics exercise. I hope this helped clarify your doubts. If you liked this video, don't forget to give it a like and subscribe to the channel for more videos like this. Hit the bell to receive notifications whenever we publish new content. Leave your questions and suggestions in the comments. We loved hearing from you and it helped us improve. Share this video with your classmates or friends who are also studying engineering. Thanks very much. See you later.